students. Join the student. Can I use that one? Thank you for taking the time to attend this morning. Let me introduce the audience for the students. A group of students. They should be from the student class, the academic class, and also I came from class and science. And also we have six students from France. There are 3 months. So, uh, Professor Mina this morning will deliver the presentation entitled Functionally Graded Material for Achievement for the Children. Yesterday, she already did the presentation of what is agency by the job. In this morning, she will explain in detail about FGM is become a star research, for recent research today because it tailor and gradually mimics the mechanical property of natural material. How its application for adhesive bonded joint, please pay attention, pay attention to her presentation. Let me talk in bahasa to our student, Professor. Anda sudah mengerti tentang FGM, Functionally Graded Material, ya. Jadi kalau secara mudahnya, ya, itu adalah suatu struktur, ya, suatu struktur yang memiliki sifat material yang dia secara gradual, ya, graded, secara pelan-pelan berubah dari satu sisi ke sisi yang lain. Nah, ini menjadi topik riset belakangan ini. Ya. Jadi banyak sekarang orang meriset aplikasi FGM ini pada berbagai bidang. Yang kemarin diceritakan di bidang apa? Penerbangan, ya. Apalagi sekarang diperlukan yang namanya penerbangan atau body structure untuk pesawat yang sangat ringan, khususnya untuk drone, ya. Jadi drone, coba bayangkan drone apa itu? Kalau dia pakai keling, dia pakai las, jadinya berat. Tapi dengan adhesif ini, dia akan sangat-sangat ringan. Ya. Jadi nanti akan dijelaskan, ya, aplikasi FGM ini khususnya untuk adhesif bonded joint yang di kelas elemen mesin. Kelas saya belum ada ya di sini, ya. Nah, karena saya beri tugas. Oh, kelas saya. Nah, nanti absennya dengan menulis resume, ya. Kehadirannya dengan menulis resume. Kalau kelas lain terserah dosen yang lain. Okay, in this session, as usual, we have a presentation and question and answer session. For the presentation, the professor will deliver the material until 90 minutes, yeah, maximum. It is okay if you want to promote your research team or research activity from your campus, no problem. If you want to introduce in presentation. And also you want to promote your campus, maybe some student will want to pursue the study in Turkey, maybe. Okay, no problem. Okay, and the remaining time, around 30 until 60 minutes, we will have question and answer session. And the good news one is the committee prepare for the three questioners with best question. We will have credit top up for your GoPay balance for three best question, not for three earlier questioner, tapi three best question, pertanyaan tiga yang paling baik. Siapa yang menilai? Nah, nanti yang menilai Pak Alif. Jadi kalau yang tanya ada 5 orang, nanti 3 pertanyaan yang paling bagus akan dinilai sama Pak Alif. Okay, let's start the presentation without further ado. Prof. Mina, the floor is yours.
Thank you. Thank you very much. Good morning, everyone. This section, our title is Functional Graded Material. Firstly, I prepared the contents. Firstly, we will learn what are the functional graded materials, type of them, and process technique, areas of application, advantage, and difficulties of the FGM. And I want to show you a study example is related of the metal matrix composite. And I want to show you FGM modeling in the ANSYS and Abacus. And we will discuss case study is related at that time polymeric material matrix is reinforced by the graphite in the macro size. And another study is related of the backlink behaviors of the functional graded polymeric. It was a thin walled hemispherical shell. It's based on the shell theory. Firstly, we can say in the material science, functional graded material, it may be characterized by the variations of the composition. Its structure gradually over volume. And for result, corresponding to change in all mechanical properties of the material. And they can be designed for specific function and of course specific applications. Due to their material properties, it's attracted a great amount of the attention, especially aerospace and especially your departments, biomaterials, biomechanical, and engineering, of course. I want to show you representations of the modern material hierarchy. Firstly, we studied in the base materials. I mean that periodic table materials. And then we studied inorganic and organic materials. We studied general metal, ceramic, glass. And then we studied elastomer and polymer. And in nearly 15 decades, we take considerations of the advanced particles, fibers, like a foam, we use in the engineering applications. And then now we are using of the FGM, functional graded materials. In case of this approach, its inverse design procedure is followed where the choice of the basic material integrals and material process that are combined with the three-dimensional mechanical analysis to form gradient structure and components for demanding application. What does it mean? FGMs, they are innovate composition materials whose composition and microstructures is vary in space following predetermined law. You can see a constituent of the phase A and you can see a constituent of the phase B. And the gradual change in composition and microstructure It's give place to gradient properties and its effect of its performance, of course. First FGM was developed in Japan in 1994 as a result of the Spain Plane project. But also, the concept of the FGM is recent and many materials that fit the descriptions have existed for decades. I mean that FGM also occur naturally. Bones and teeth and maybe seashell is a good example for them. I want to show you some natural occurring of the FGM. Look at a human skin. It's a skin structure. It's gradually. And a bamboo tree. It's also a good example for a functional graded material. And a bone. Bond is also, it's a good example. Can you see it's a crochet layer? So they are naturally occurring of the FGM. When we look at the tooth anatomy, you can use and you can define it gradient structure and structure type of the bone. You can see its material is different to its directions, of course. What about its application area? FGM is used in especially space applications, rocket components, space plane frame, and they are using of the nuclear reactor, fusion pellets and plasma wall, and others they are using of the building materials and sport goods, and communications like optical fiber and like semiconductors. It's applications areas. You can see a rocket stress chamber. You can see a artificial hip joint. They are a good example for FGM. It's FGM has a specific material because they use of the different thermal barrier materials. Look at the plane structure, it's basically, so it's necessary different thermal gap. You can see in the red one is the hot one, and you can see inner of the plane, it's different Celsius. So interest in the FGM is escalated due to the ability of the produced material, which suitable indicates numerous of the high technical applications. So its important specifications has a thermal barrier materials. I want to tell about its classifications. Its classifications according to the different criteria, but we have just only main two criteria. First one is constructionless structure, FGM. It's continuously. You can see a metallic pulse is the dark one, and the ceramic pulse is the dark one. Please look at transition region. This region is, and this region's size is important for us for mechanic or for material science. And the other one is discontinuous layers of FGM. I mean that like that is layer by layer. Ceramic metal matrix and ceramic inclusion, and again metal matrix, layer and layer FGM. According to the process manufacturer, we get thin FGM and we get bulk FGM. For example, this is used by metal and ceramic, metal and metal or metal are intermetallic. You can see as example, and this use of metal and polymer. And then you can see variations of the porosity. It's a single material. It's variations of the glass and ceramic. It can take a considerations of the FGM. What about its advantage? Yes, it's important part. Functional graded materials as a interface layer to connect two incompatible materials. They can greatly enhance the bond strength. And FGM coating and interface, it can be used to reduce residual stress, and it can be used to reduce again thermal stress. FGM coating are not only enhance strength of the connections, they but also reduce crack driving force. But we have some difficulties, of course. For example, a proper database of the graduate materials and material preparation and the performance is developed with difficulties of these material. We still need further and further research and examinations of the physical properties of the material model, and also it's difficult for modeling of this type of the material in the numerically. Modeling and get a physical properties is hard. Microscopic structure and then the quantitative of the relationship between of the preparation condition to be established in order to accurately and reliably physical properties and the gradual materials. Yes, it's thin material is generally manufactured with different methods. It's physical vapor deposition and high temperature synthesis and many manufacturing methods, but it's not our topic. And the while FGM manufactured by methods like power metallurgy technique and centrifugal casting method, especially I'm insist talking about centrifugal casting method and solid free-form technique. It's additive manufacture method. Maybe you know that. This process technique, firstly, vapor deposition technique. Its technique is used to produce all the thin functional graded materials, and it's used to deposit functional graded surface coating. It's a method for coating. And it gives an excellent microstructure, but it's a problem. It produces pollution gases as the air by their products. So we don't prefer it because of it's produce pollution gases. Another method, I'm sure you know that, a power metallurgy technique. In the power metallurgy technique, we are mixing of for example, a ceramic and metal, and we are stacking layer by layer from the lower pressure, and at the room temperature, we use of the compression by hydraulic press, and after we just only sintering by using of the thermal, not pressure. Pressureless sintering, and then we get FGM. It's a method. We use it, why? Because we have two main materials. One of them is metals. It has a specific material properties. Its toughness is good and ductile and is ideal for engineering applications, but it's not enough because we need a high temperature resistance. So we take a considerations of another material. It's a ceramic. Yes, it has a high thermal resistance and low toughness, but It's a low toughness. It's a problem, and it's brittle. So ceramics that cannot be directly used in engineering applications. But FGM, I mean that both ceramic and metals, it's produced of the FGM, the best both high strength and also high temperature resistance. Our aim is that. I want to talk about Suri reform technology. It's You can know it's the name of the additive manufacturing technology. We generally use generations of the CAD data from the software, generally use SolidEdge, and the conversions of the CAD data to the STL forms, standard triangle language, and slicing of the STL forms in two-dimensional cross-section profiles and building the component layer by layer. Using of the solid EDGE, and the CAD process is from the data from the STL, and it's a method of the additive manufacture method, stereolithography, and you are sliding of the layers of the data, and in the platform by using of the laser is hardening of the first layer, and then hardening of the second layer is hardening of the last layer. It's a technique for get functional graded polymeric materials, and it's recently used functional graded metallic materials. Yes. What about the centrifugal casting method? This method is manufacturing process is used to create cylindrical components with centrifugal rotation. This technique is involve rotating a mold around a central axis at a speed typically ranging from 300 to 3000 RPM, and while pouring molten material into the mold. So I use all this technique, and I have a laboratory from Silesian University in Poland, and I use that, and I want to talk about this technique for the polymer materials. And I will show a study for the metal materials, metal and silicate carbon. You can get it's a rotating mold from its axle, and we are pour into the first layer, and we are adding of the second layer, and we can get a centrifugal cast method. This is an old but good example for characterizations of the functional graded material for aluminum silicate carbide. Metal-to-metal matrix is manufactured by centrifugal casting method. These are my friend from Egypt. It's not mine, they used variable frequency control of the mold rotation speed in this range of the 500 and 2500 RPM, and this control access speed of the feeder tube is range of the 5 and 50 millimeters per second. Look at that. You can see a functional graded aluminum matrix composite prototype components. It's a cylindrical liner, and it's a brake rotor, and it's a piston. They are manufactured by using of the centrifugal casting method. And you can see its figure from the aluminum graphite and aluminum zirconium metal-to-metal matrix composite. I want to show you its SEM process. You can see in the microstructure, all of the aluminum silicium carbide, it's hollow, cylindrical. It's fabricated by horizontal centrifugal casting method. So they take a considerations of the experimental data. They different from outer periphery towards to the inner periphery in different positions. You can see in the outer, of course, they are crowded. You can see in the inner part, yes. And we take a considerations of the transition region. It's important for us. They are pure aluminum. They're used as a metal matrix composite, and it's aimed to reinforce its mechanical properties by adding of the silicon carbide. Why? The use of the aluminum silicon carbide particles. The usage of the silicon carbide metal matrix composite is constantly increasing in the last year due to its unique properties. It's a lightweight and it's a high strength and high specific elastic modulus, high fatigue strength, and its hardness. They choose at these particles for adding to the metal. It's a melting. Melting of the base material in graphite is crackable at the 670 degree, and heating to the pouring temperature is 725 Celsius degree. And silicon covered particles is added at different weights of the person's age, not volume. It's different weight of the person's age. You can see 5 different percentage, 2.5, 5, 7.5, 10, and 15. And it's a 3 different size of the silicium carbide adding at the metal matrix. Different size. For example, is 500 micrometer particle and 23 micrometer particle, and the smaller one is 16 micrometer particle adding at the metal aluminum. I want to show you its procedures of the procedure. Why? Silicon carbide particles are mixed by the state, and the mix is poured into the centrifugal casting machine, and they have been just into the different rotation space. It's an option to produce of the FGM tube, and its outer diameter is 230 millimeter, and the wall thickness is 12 millimeter. And whole length is, you can see, all the 180 millimeters. I want to show this example because to understanding of the determining of the mechanical properties. Firstly, it's we manufacture it, and then we don't know its properties. The all engineers, you and me, we have to be in mechanical properties in the materials because of the we used in any machine. So we have to describe it. We can take a considerations of the tensile samples according to longitudinal, and we can take a wear samples, and we can say the microstructure and hardness sample from this thickness. Remember that it's 12. And I will show you some mechanical properties is changing according to the axis and changing according to the inner and outer direction, of course. Is These samples were sectioned, and these samples have been first polished and it's attached by hydrofluoric acid. And then we use of the macroscopic examinations. It's performed a optical microscope. Generally, I use of the light microscope and optical microscope, and we use of image processing methods. The differences in the distributions of the silicium carbide particles in the aluminum matrix has been by image processing method by using of the light and optical microscope. Look at that. It's a outer zone. It's the outer zone and it's the inner zone. I want to show you a different size of the silicium carbide adding material and different size. This example is belong to the 23 one. What about of the chill zone? Chill zone, it's mean that it's the nearest area to molten wall. So it's chill fastly. You can see a microstructure of the functional graded material. It's for silicate carbide. At that time, its weight ratios is 16. And then it's the biggest one. If we can choose of the silicon carbide is 500 micrometer. They get a microstructure. But I want to say, I want to show you this structure is outer zone and this structure is inner zone and transition structures, both of them. What about of the particle analysis? I said that image processing program, they have been applied. And we have some software. ImageG software is popular one. This program to analyze of the distribution. And this program, the number of the silicate carbide particles. So mathematical tools is detection. They have been defined, it's ADGE, it's count particle, adjust the contrast of the count particle, and this program is calculating all the relative concentrations is adding particle. For example, for the different phase ratios, can you see effect size of the distribution? The value is not important for us, but please see its behavior of this line. It's please remember thickness. Thickness is the hollow part is 12, so I can use x-axis 0 to 12. Attention that its concentrations of the silicon carbide is this area outer zone for different adding sample size. It's inner zone. Yes, look at their behavior. And we take a considerations of the transition zone. Yes, transition zone. Yes, is bigger than for the 15 percentage of the silicium carbide when we adding. And also another effect is, of course, rotation speed. Effect of the mold rotation speed on the distribution particle, it's a effect, and you can see differentiation. And pouring mechanism. Effect of the pouring mechanism of the feed. Distributions of the particle. And you can see it's 28 millimeter per second feeding, and you can see is 16 millimeter per feeding is different. This feeding concentrations of the silicium carbide and this feeding. So I mean that these experimental show us take a considerations of the feed mechanism, take a considerations of the size of the editing part, and take a considerations of the centrifugal casting speed. Of course, it's an important part. What about of the mechanical testing? We use of the Bernal hardness test. I'm sure you know that. Bernal hardness tests that have been conducted on the specimens is varying of the weight fractions. It's this particle. In the hardest testing machine has been used this load and this cell ball intended of the 5 millimeter diameter. In that Bernal test, we use of the steel ball and we contact at the surface area by using of the load, and after that we can calculating of this area and this depth. So we decided of its hardness. Look at that. It's a Bernal hardness is according to the weight of the fractions is changing. What does it mean? Is the inner zone, outer zone, and transition zone that has different Bernal hardness. Yes, it's expecting, of course. And you can see of the just only outer zone, because outer zone is most crowded and most hard area for us. Bernal hardness of the outer zone, you can see, is different size of the shape silicon carbide material. I want to show you, it's of course is related to the weight of the fraction, and we can changing of the hardness tubular sample by using of the according functional graded materials by using of the centrifugal casting method. What about all its mechanical properties for elastic modulus, position relation, shear modulus? We need them, of course. So we can take a tensile space. We can take a tensile sample from this site. We cut the sample and we grid by the paper, and we can calculate the tube thickness to investigate of the effect of the particle distribution throughout the thickness for each studies by each weight of the percentage. And the tensile test and the elongations of the fracture, they were determined by using of the tensile test machine. You can see is ultimate. You can see all the ultimate straight. What is the ultimate straight? Tensile strength. Yeah, we can draw of the graphite stress and strain, and they are using of the ultimate is a top strength. Not I don't want to be in rupture. I don't want to be in a break strength. It's ultimate strength. Ultimate strength is according to the ductility. You can see all the is different size of the silicon carbide. It's changing, and also its distributions of the ductility is changing of the another silicon carbide weight fraction. Yes. And conclusion. I want to give some conclusion about this technique. This is the old and base technique. It's a metal to metal by using countercentrifugal casting. So investigations of the macrostructures reveals that concentrations of the silicium carbide particle in the outer zone of the cast tubes, its reach maximum volume, it followed by gradual decrease in directions of the inner diameter. In case of the large size and in case of the higher rotation speed, all fabricated tubes reveal high concentration is reinforcing particle in the outer zone and due to the higher centrifugal force and bigger particle mass. At a higher axial speed of the feeding tube, the concentrations of the outer zone is higher than obtained the lower speed of the speeds. And the gradient of the concentrations is reductions in lower feed conditions in the lower than gradients obtained the higher feed. So the result is smoother change of the properties. It's according to the thickness. The ultimate tensile strength, there has been found proportions of the percentage of the silicium carbide silicate carbide and inversely proportional to the size of the particle. And maximum improvement of the wear resistance, it could be achieved in the range of the 7.5 and 10% of the silicium carbide when adding of the metal matrix composite. I show the experimental data and it's a good example for metal matrix composite. And I'm giving you a method, centrifugal casting method. What about all its analyzing?
Yeah, there is some explanation about the FGM. So we can compare to conventional adhesive bonded joint. Adhesive bonded joint maybe only have one property of material, but for FGM, it will gradually change from the one side to other side. So that's very interesting. There are so many research paper published in this area, and the concept of AGM is actually appropriate for many applications in engineering and maybe become key solution to many engineering problems. But as the professor mentioned that some physical or mechanical properties need to be researched further. Okay, ready?
Yeah, sorry. Yeah, I want to show you a click point by modeling of the FGM in the abacus. Look at that. It's a chosen of the inner material is ceramic. Sorry. Okay. I'm sorry. These materials is ceramic and outer material is metal. And look at that is the radius, is inner radius and outer radius. Sorry. Okay, we are going by uh, maybe that one is Zoom. No. It's closed. Can you try it again? We need 5 minutes. Please take a rest.
Yeah, we waiting for Professor Mina. Yeah, sorry for technical problem. So you can write the resume for student in my class. Jadi tadi ada video yang ngehang di komputer beliau. Ditutup nggak bisa, di pause nggak bisa. Jadi harus saya hard, hard close baru bisa. FGM, FGM ini kalau tadi di slide-nya ya disebutkan ada yang dia sistemnya discontinue atau bilayer, ya strukturnya discontinue, ada yang continue. Jadi ada perubahan gradualnya itu secara continue, ada yang discontinue bilayer. Jadi proses coating yang dilakukan dalam manufaktur itu sebenarnya juga termasuk konsep FGM. Jadi kalau Anda punya material, Anda coating, itu sebenarnya juga termasuk proses FGM. Karena kan tujuannya untuk mengubah sifat asli material yang Anda coating, ya. Jadi sifat aslinya mungkin kasar atau kurang keras, kemudian di coating. Atau yang diberikan quenching. Nah, quenching itu kan mengeras di bagian permukaan, ya. Di bagian dalam dia eh, masih kuat, ya, masih elastis. Itu juga masuk konsep FGM. Jadi konsep ini diperkenalkan sebenarnya praktikalnya sudah banyak dilakukan. Ya, praktikalnya sudah banyak dilakukan. Cuman sekarang ke arah polimer, ya, material-material baru itu menggunakan konsep ini. Salah satu aplikasinya di bidang biomedis, ya, atau medis itu kalau beliau bidangnya murni mekanik, ya, murni mechanical. Jadi kalau saya lihat di FGM ini bisa diterapkan di situ, ya, di gigi palsu, ya, di tulang, kemudian struktur-struktur lain yang dia sifatnya tidak bisa diwakili satu sifat material. Jadi FGM bisa dicoba untuk aplikasi seperti itu.
Okay, hello everyone. I want to go in another study. This study is manufacture polymeric matrix composite materials is reinforced by the graphite. Its experimental study is related in the Poland. It's a biomaterials department. I want to introduce especially our functional graded polymeric materials. At that time, we studied it in not metal, we studied it the polymeric materials, and we again take a considerations of the centrifugal casting method. And in the graphite of the epoxy, in the gradient epoxy graphite composite is where search epoxy resin, it's epidien 6, it's cured with Z1. And they both of them produced of the Poland. And it's just only name PEM 96 and PV 60. It's produced by the Czech Republic. They are a filler and they specific properties can be shown in table 1 and table 2. We use of the its density and we use of the its content of the carbon and we use of the their range size. Sorry. What about of the additions of the materials? Additions of the respectively 3, 6, 9, and 12 volume of the graphite, it was applied. And its sample preparation, can you see in that figure, and sample diameter of the specimens, you can see. Firstly, mixing of the epoxy resin and hardener with the graphite, and it's a composition. We have this centrifugal casting machine, and we remove the sample, and it's a tubular polymeric gradient materials. You can see its diameter of this. And this speed rotations was chosen and that value, and the time of the rotation was nearly 2 hours. All material for investigations add wet greens with grinding paper and with different size on the machine presented. After the grinding samples, we polished by using of the diamond suspension, and we choose of the grain size is 1 micrometer. And during the polish sample, were cooled by a diamond suspension. And air sample. Air sample were treated by SAM processing. In order to develop the structure of the sample, we attach of the acetate pure, and etching time is 1 minute for each samples. Then all samples was observed under the light microscope, and its magnifications is 300x equipment with AxioVision software. So we can detect all the material properties according to the thickness. Can you see? Properties of the 8 rings, while each represents of the separate conditions, I mean that is the volume ratios 3, 6, 9, and 12% is graphite, it's white observed in the light microscope. And all images were taken across the cross section. We taken nearly 30 images from each sample, and we observed all picture is divided of the three region because of it's been too hard to show all the image which attached to each other is respectively. So these regions is the left column is presented of the outer part, center of the column is middle of the part, and the another column is using of the inner part. Can you see ratios of the graphite are decreases from the outer part to inner part by 30% graphite reinforced by epoxy resin sample. Decreasing of the graphite ration, and it's nearly 3.1, and for the 9% is 5.8. Its 12% is 9.6 times from the outer and inner particle respectively. I will show you this case study because of the get understanding of the we are using of the its graphite and adding of the polymer matrix composite. So it's a different to metal. It's a polymer. And you can take out the area of the graphite. We use of the light microscope, and we use of the image processing program, and we detect all graphite according to the thickness. This is important for us because our sample has different properties of the material. You can see is this figure is belong to the 3 p.m. sample, and this is belong to the 6 p.m. sample. And you can see it's hard observations. It's not clear like a metal. Metal is simple, but polymer has some difficulties for observation of and detecting of the size in the particle. And I will show you is the nearly PAM samples is decrease of the 3.1 outer the inner sample. What about alterations of the graphite area is outer part to the inner for 3 PV sample. And the column chart, I will show a column chart, both of them. You can see, yeah. We can contributions of the graphite particle alter the layer in the directions of the inner particle. We can use of this diagram because we can take a considerations of the properties of the this sample. This is a tube sample. You can see PV and PAM is different type of the graphite types. So we are discussing at that it's possible to, of course, produce of the polymer gradient materials by centrifugal casting method. And the distributions of the reinforce on functional gradient materials is, of course, non-homogeneous. And it's all amount of the graphite was located is nearly 1.5 millimeter in the external diameter. And then is a maximum graphite ration on the external diameter is 12% ration graphite PV material. And what about of the minimum graphite rations on the inner diameter is observed with the 6% graphite in the PEM material. So this study was carried out in order to evaluate of the percentage area of the distribution in that through gradient composition. After that, we observed all particle we used in the analysis. These analyses is published in the name Backlink Behaviors of the Functional Graded Polymeric Thin Wall Hemispheral Shell. Maybe you know that we have three different main geometry in the mechanic. We use of the beam, we use of the plate, and we use of the shell. And this in that study, the formations of the shell theory was used. What about of the spherical shell? Spherical shell, they are important structure components because they frequently anchored in different engineering area because it's a specific geometry. So these hemispherical shell are very effective in the resisting in the external loading. So in general, this value of the backlink load, it depends on the shell geometry and material properties of the shell, of course. So the static backlink behavior of the spherical structure made of the different material at that time for isotropic material, orthotropic material, and but is recently many authors is focused on the mechanical behavior of the functional graded material spherical shell and their industrial application. The use of the underwater, the behavior of the underwater FGM shells has received a much attention on the literature. FGM spherical shell as used submerged domes, and they can use of the shell storage containers. And due to the increasing of the spherical shell made of the FGM, it's important understanding of their stability characteristic is essential for designer and for us, for engineering. This new functional graded polymeric materials is based on experimental study, and it's performed of the analysis for determining of its backlink behavior subject to the external force. I talk about of the epoxy regime and was used of polymeric matrix, and I talk about its graphite powder material, its PAM and PV. Okay, we observed the material and we write the table in the 5 region of the outside to inside. For the percentage of the graphite, their density can be seen. And then its model. The predictions of the Young modulus in the 5 region is necessary. So we have several empirical model, the Young model of the polymer of the composites. One of them is Good model, one of them is Brighton model, the other one is Half-Tsai and Paul model. Look at that, it's the Half-Tsai and the Paul model were used to determine the elastic modulus of our experimental FGM parts, and we will compare each other. You can see these equations of the model is the below, and Paul model is used to predictions of the elastic contents and multi-mass materials. They're using of the polymer as Young modulus, they're using of the filler elastic modulus, and it's important of the volume relation. And the Half-Tsai model widely used to predict of the modulus of the polymer composite. And then it was determined of this equation. In that is Kc as a Greek letter. Kc is a shape factor. It depends of the on geometry of the filler particle. So in our filler particle shape was flake, and it can choose of the 5.1, and the parameter of the n by determined of these equations. It's just a method. It's a half psi method. And you can see a simple hemispheral shell. In the backlink of the problem, in the homogeneous isotropic thin-walled spherical shell, subject to the external pressure, was solved by Zoli. So we use, firstly, we get the model and we define its homogeneous isotropic, and we are subjected of the external pressure load, and we will check is our critical backlink load, mode 1, mode 2, mode 3, etc. And we validations in the theoretical method. So we decided that the model is okay, and then we changing of the material properties by taking from the experimental data. So take a considerations of the radius is 40 millimeter and thickness 1 millimeter. You can see is many gradient. It's not like a layer by layer because it's interfacial problems. Please imagine that is a material properties changing from the directions in these models. In the boundary conditions, they are fixed Ux, Uy, and Uz. It's not allowed the deflections. And then we using code is ANSYS. It's from ANSYS. Its finite element method was built by using of the shell elements because it's a shell. And the boundary conditions you can see. We discuss about of the two models. Firstly, its axis is related to the volume of the PM, and the other axis is volume of the PV. Because in the experimental, please remember that when we get an experimental, we adding of the 3, 6, 9, and 12% of the PAM and PV graphite, and we take its critical backlink load in the first mode. So we use of the half-psi model. Its behavior is like that. We using of the Paul model, its behavior is like that for PAM, and another graph is belong to the for PV. We take a considerations of the many modes. For example, I can take 8 modes for you. The critical, the pressure, the backlink pressures is volume calculate, and differences of the values of the critical pressure, it's not exceeds 6% for the all graphite. You can see combined of the two model, half and psi and full model. And this result is show that the critical backlink pressure is determined by the half-psi model is more coverage to the analytical result than determined by the Powell model. Because since the half-psi model is considered of the graphite shape factor is different from the Powell model, so the result is possibility. In that figure, we can see of the critical backlink pressure by changing of the graphite volume ratio. In the Paul model, is critical backlink pressure was determined of the 20.4% and 20.7% higher than the half-psi model. And then the analysis show us the Paul model predicted the overestimate the critical backlink pressure in all graphite and volume type. After the finite element analysis, we need validations of the finite element analysis. The value of the critical pressure as take a considerations of the homogeneous material as a steel, and by using of the numerical method. And the critical pressure was analytically determined in this literature was obtained in 151.3, and the wall thickness in the hemispherical shell was taken into consideration is 1 millimeter. And then is given study, the present finite element analysis is applied for the steel material, and the results were compared for the analytical and the FEM solution. So the differences is not big. The gap is nearly 1%. So this pointed is precision of the presented point element is analysis is good and is validation. We have some conclusion. In that study is based on is recently experimental work. And then it's important, it's functional graded polymeric material, and it's using of the light microscope and image processing program, and it's a finite element analysis is specific, and then it's just only two empirical model is discussed. The result is that our mind of the half-psi model is more reasonable and more reliable due to the including of the shape factor. And then the best, the selecting of the PV graphite was the better to increase of the backlink strength, and the highest backlink strength was obtained the 12% of the volume ration. And then the present interesting results can be useful of the stability problems of the FGM hemispherical shell, and we hope it's good for similar industrial applications. Thank you for your attention. Thank you.
Okay. Thank you, Professor Mina, for a very detailed presentation. Now we move on to next section, question and answer session. I will give two a question first for the first session. Okay, please raise your hand and mention your name, and then you can ask the question. Okay. Please raise your hand. I want to remind you that there are some gift for the best question. Yeah, the best question. Okay. Give the microphone to. Yeah, mention your name.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Hello, Miss. My name is Diaz, and I'm a first year student in mechanical engineering. So because it is my first year, so I don't know much about the subject. So I want to ask about what industry that is most likely to adopt the FGM, and what the specific benefits that it offers compared to the other material. Thank you.
Thank you. It's a reliable questions, and you're encouraged. Generally, FGM materials is preferred in this submarine, because in the submarine conditions has different temperatures. You know, the other side is water, the inside is need for a human healthy air condition, and maybe it's firstly about thick shells is preferred of the with submerged domes. Submerged domes. Please think about is just a door, it is submarine door. So it's necessary and it's a unique properties of the material, especially of the submarine. Thank you.
Is that clear enough for you? Okay. Any other question? Please raise your hand. Yeah.
Thank you. Excuse me. My name is Jacob, and my question is: in making a composite, we will choose to determine the matrix and the reinforcement. So whether the behavior of the material is influenced by the geometry of the reinforcement.
Uh, he asked that if the behavior of material influenced by the geometry of the material. Ya. Tolong diulang, yuk.
Uh, is the behavior of the material is influenced by the geometry of the reinforcement of the composite?
Side, ya. FGM.
Yes. Um, especially, I talk about centrifugal casting method, and it's some basic parameters. In the first basic parameters, can you remember in the metal-to-metal composite matrix, it's silicon carbide. They add all the silicon carbide to the aluminum, and its parameter is the shape of the shape of the silicon carbide, and they investigated of the 500 and then 26 and 23 and 16, and it means that it's different shape. So they want to decide to which shape is suitable for its unique properties or unique usage area. Of course, adding material, its microstructure shape is important. And also in the theoretical view, we learned in the model, in the power model, take a consideration if the C is a shape factor, and the shape factor is like a spherical or flat. And in that application, in my experimental applications, is this is a little thickness, another dimension, so it can be accepted in the plate. So we can take a shape factor is 5:1. I'm not sure. Of course, its shape is important and dimensions is important also. Thank you for reliable questions.
Yeah. So in simply that the geometry of the matrix, yeah, inside the composite of FGM will influence or interference the mechanical behavior. So if you change the matrix geometry, yeah, the shape factor, she said, so it will influence or change the mechanical property of the model of the body. Okay, the next session, more to question. Okay, mention your name.
Okay, my name is Taliban. Thank you for the opportunity. Okay, Prof.
Taliban.
Just on my question is considering the advantage of functionality graded material in mitigating residual stress and connecting incompatible materials. What are the biggest challenge in developing and implementing FGM processing technique, particularly for large scale bulk FGM component compared to thin film FGM?
The big challenge.
The big
to
challenge
develop
in developing and implementing FGM.
between what?
Uh,
Yeah.
book book FGM component and the thin FGM component.
Thank you, I got it. I will show you.
Okay.
It's a processing method is dividing by the get your aim. If you get tin or book FGM, it has different material. So in the tin FGM material, we generally use coating. Can you get me? FGM coating. So this material just only coating the another material. So I using of the power deposition technique. It's just only slide by slide by slide, just only covering. But in the book material, so we decided to take a whole structure in the FGM. We prepare the book material. Tin is just only coated method. These are the big differences between of them. Thank you.
So in bulk material, you use powder metallurgy. What technique you use in for bulk material, bulk FGM? Yeah. Hmm. Hmm. Still in experimental data. Oh. Yeah, any more question? Are you clear with the answer, Mr. Taliban? Are you clear with the answer?
I think the biggest challenge for the developing.
Yeah, she mentioned that for the bulk material, FGM material, still in developing in the experiment, not in industry. So for the thin film, already tried, already produced by industry by vapor deposition technique. So for bulk material, still in research in the laboratory.
Okay, thank you.
Yeah. Okay, more question? Okay, the right side.
Okay, thank you. My name is Rian Ramati. I have one question. Do material have specific requirement that need to be, or can any material potential be used as FGM? Thank you.
Sorry, please.
Okay. Do
Repeat.
material have specific requirement
Mhm.
that need to be met, or can any material potential be used as FGM?
Any specific requirement for FGM, or we can use any material, organic material maybe, for FGM.
Generally, we are researching into metal. I will show the example. Generally, we use all the ceramic of the metal because ceramic not used all the directly in the industrial area. For your asking questions is related if related in the industrial area. It's a titanium carburant. Nitride is a good example. And then metal, yes. And then metal polymer, it's aluminum and carbonate. So FGM, we have using of the ceramic and glass, but what do you want the organic material? If you accept in the organic material by this hierarchy, elastomer or polymer, you can add in code and a polymer. ABS is organic material, is based on the corn. Maybe it can add ink, but it's not my area in organic material. So it's generally used metal and ceramic material, but maybe it can be used as adding of the filler. I have to check the literature. I'm not sure the answer now.
So she said that that is not his research area in for organic, organic material in FGM. But we can see the application of FGM in the biomedic, like for dental or for prosthetic bone. This is combination between elastomer or polymeric material like PMMA or PEEK, yeah, polyether ether keton, combined with HA, apa ya singkatannya? I don't know the Stanford. It's Stanford. So the HA or HA in bahasa it combine the organic material to this material. Yeah, this is some application, another application for FGM. But she said she has not any experience in that area. So the answer is very possible, but limited for biomedic.
Yes, please think about it's a high advanced experimental material. It's not a commercial material. It's not an industrial material. Okay, it's just on a high advanced material for science.
Okay, any more question? Are you clear with the answer?
Yes, I agree. Thank you for that
Yeah,
answer.
you're welcome.
Thank you. Thank you.
Thank you. Already 4 questions. If there is still some question, yeah. Any question? I give. Yeah, thank you. The time is still possible for next question.
Yeah, thank you for the opportunity. My name is Musharrafa. I want to asking to Professor that how does the distribution of transformance particles, such as silicon carbide, within the adhesive layer affect the mechanical properties and fatigue resistance of the adhesive joints? Yes.
And the
Thank you.
fatigue, yeah, okay. They use your questions is related to the adhesive bonding joints. And you're asking me if the adherent material are chosen of the FGM. Am I right? Yes, okay. Your questions is discussion with the specific geometry of the fatigue. And when we are discussing of the fatigue, it's the most important thing, that it's a crack, as crack notation. And we have some different modeling by discussing of the fatigue. So we can discuss if we accept of the crack in the adherent, we defined in the crack tip, and then we use some technique. For example, virtual crack closure technique. It's some technique for get the fracture and fatigue behavior. So it depends your aim and it depends of your geometry. But I want to teach you and I want to discuss, I want to talk about you is functions of the gradual material. It's a specific and the another lecture, the next lecture we used in adhesive bonding joint. And I will show you some case study. At that time, adherent is choosing of the FGM, and then it's glued to each other. It's plate and beam. I will show some example, and we will discuss tensile, we will discuss bending, we will discuss some backlink properties. But its topic is related to the next lecture. Yesterday I talked about adhesive bonded joints, and today the first lecture in the morning FGM, and the afternoon the lecture is related FGM with adhesive bonding. please attend it.
Are you clear with the answer? Okay, thank you. Any more question? Okay.
Okay, thank you for the opportunity. My name is Muhammad Salman. I'm currently a final year student of mechanical engineering. I just want to know about the FGM application. So basically, you mentioned that in aerospace there is some application and about FGM. Is there any consideration for type of plane? Like we know that aerospace in airplane we have to type which is a narrow body and also wide body. Is there any specific plane that can apply by the FGM method, or any plane can apply this method? Thank you.
Uh, so your question is, can we apply FGM to any plane or specific plane only? Yeah. Yeah, maybe it is not suitable question, but what do you think? Can we apply the FGM bonded, adhesive bonded to any plane? Yeah, plane, airplane, or specific airplane.
Um, it's it can be preferred like a just only coating, but not a bulk material. If your aim is coating in the metal in the airplane body, it can be used by a problem of the thermal problem, but it's just only thin FGM can used by the coating.
So the application industrial now is only coating, thin coating FGM, not for bulk FGM. Still in research. So yeah, need more research again to apply the concept of FGM for bulk material. Any more question? Maybe for the last question. May I have question for you? I want to know about the ANSYS application, ANSYS software. Because yesterday I don't attend your meeting, your presentation. How to apply the properties material for the layer by layer? Do you get by experimental method for then apply the result to the ANSYS or what?
As a click points, we generally define all the FGM materials by accepting of the thermal coefficient factor is equal to the 1. I want to show you a video, but it was problem. Yes. Firstly, we plan image that a functional graded material plate. And think about ANSYS. We choose firstly the analysis type with a structure, and then we choose all the plane elements. Maybe it's choose plane 55. It's not important, and then we take considerations of the mechanical properties. We choose all the mechanical properties. Adding of the a file. So we firstly prepare it on the Excel file, and the Excel file has some charge. Uh, Maybe it's a hollow part, and the distributions of the mechanical properties is changing by the thickness. So you can write of the inner thickness, you can write of the outer thickness. The first column is related of the thickness, and these firstly before the get a model, it's need of the based on empirical model. Maybe I use of the and I show the whole model, and you can write empirical model, and you are you know that elastic modulus, for example, of the metal, elastic modulus of the ceramic, and you use all the equations, empirical equations, and you draw under the another column is elastic modulus metal, elastic modulus ceramic, and elastic modulus of the PV. And then another example, for example, you can calculate in the thermal coefficient. And at this click point, firstly, we solve all the plate structure by structure analysis, image that loading of the internal load. For example, we firstly solve that. And then the second analysis is chosen temperature analysis. So we are adding all the temperatures, different temperatures according to the it's proportional with your Excel table. And the click point is please choose thermal expansion coefficients is equal to 0. So the answer is can calculating all the mechanical properties, not adding all the thermal effects, but not please not adding all the thermal conductivity. Thermal conductivity factor is not equal to 0. Say something, it's not important, but the click point is adding thermal coefficient factor is 0, and then it get a text file and is amperage money again solved and it's definitions of the FGM basically.
Thank you for the answers. I think this is enough for the session. Last opportunity. Any more question, maybe? Okay, finally, everyone, we have come to the closing session. We would like to express our gratitude again to Professor Mina and all the audience member for their active participation. Yeah, give applause. Thank you very much. Hopefully, this presentation will benefit all of us. Thank you for your active presentation. Have a great day. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Yang belum absen, jangan lupa absen ya. Di scan barcode kanan kiri kalian. Terima kasih. Untuk pembuatan e-sertifikat.